The first humans to set foot on Mars might never come home. Not because of a disaster or failed mission, but because returning from Mars is so monumentally difficult that making it back to Earth could be physically impossible. This isn't science fiction speculation. It's what the physics, biology, and economics actually tell us when we strip away the optimistic PR campaigns and face the brutal realities of interplanetary travel. Right now, space agencies and private companies are racing toward putting humans on the red planet within the next decade. They talk about Mars colonies, about making humanity a multiplanetary species, about the next giant leap for mankind. What they don't emphasize is this uncomfortable truth. The first Mars mission might be selling one-way tickets disguised as round trips. The idea of a one-way Mars mission isn't new. Space activist Bruce Mackenzie stood in front of an audience at the 1998 International Space Development Conference and proposed exactly that. He called his presentation "One Way to Mars, a permanent settlement on the first mission," arguing it could be done with less difficulty and expense than bringing people back. At the time, it sounded radical. Today, when you dig into the actual engineering challenges, it starts to sound inevitable. Buzz Aldrin, the second human to walk on the moon, has been even more direct about it. He's compared Mars settlement to the Pilgrims on the Mayflower. They didn't sit around Plymouth Rock waiting for a return ship to England. When you go to Mars, Aldrin says, you need to have made the decision that you're there permanently. Coming from someone who actually left Earth and came back, that carries weight. The question isn't whether we should send humans to Mars. That ship has sailed. Multiple nations and private companies are already committed to the attempt. The question is whether we're being honest about what that journey actually means for the people who take it. If you find comfort in these gentle explorations of space and science, I'd be grateful if you'd consider subscribing and giving this video a like. Let's start with the most obvious problem. Getting off Mars is nothing like getting off Earth. When Apollo astronauts left the moon, they were working with 1/6 Earth's gravity and no atmosphere to fight against. Mars has about 1/3 Earth's gravity, which sounds manageable until you realize that's still enough to make launches extraordinarily difficult. And Mars has an atmosphere. It's thin, just 1% of Earth's atmospheric pressure, but it's there, creating drag and heating during ascent. To launch from Mars back to Earth requires a complete rocket, fueled and ready to go, sitting on the Martian surface waiting for astronauts who might not arrive for years. This Mars ascent vehicle would need to be sent ahead, landing safely, despite weighing tons fully fueled. Except here's the problem, it can't be sent fully fueled. The vehicle would be too heavy to land safely on Mars if it carried all its propellant from Earth. So the current plan, the one that agencies and companies point to when asked how return missions work, involves making fuel on Mars itself. The technical term is in situ resource utilization. The reality is far messier than the acronym suggests. Manufacturing rocket fuel on another planet means setting up an industrial chemical plant in one of the most hostile environments humans have ever encountered. You'd need to extract water from Martian ice or soil, split it into hydrogen and oxygen, combine the hydrogen with carbon dioxide from the atmosphere through something called the Sabatier reaction, and produce methane and oxygen propellants. Then you'd need to keep those cryogenic propellants cold enough that they don't boil away. Despite temperature swings on Mars, ranging from -125 degrees Celsius at the poles to 20 degrees Celsius at the equator during summer. Currently, we don't have valves with zero leakage for cryogenic fuels, not even close. And this fuel would need to sit in tanks for potentially 4 years. 1 to 2 years to manufacture the fuel, then 200 to 350 days while the crew travels to Mars, then up to 500 days of surface exploration before the launch window opens for the return journey. 4 years of waiting for fuel that might leak, freeze solid, or boil away. The power requirements alone should make anyone pause. Early concepts talked about tens of kilowatts for propellant production. More recent analysis suggests hundreds of kilowatts would be needed, possibly requiring a 1 megawatt power system. That means 25 of the 40 kilowatt fission power units NASA is currently developing. That's not an incremental challenge. That's a 100-fold increase in power infrastructure, all of which needs to function autonomously in an environment where dust storms can last months and temperatures regularly drop below anything experienced on Earth. And that's assuming you can find accessible water ice at your landing site. Mars has water, frozen in the polar ice caps and potentially buried in subsurface deposits. But potentially buried means you might land at your carefully selected site and discover the water is deeper than your equipment can reach, or locked in minerals that require processing techniques you don't have, or simply not there in the quantities the orbital surveys suggested. This isn't pessimism. It's what happened with Mars One, the Dutch company that promised to send humans to Mars for permanent settlement. They attracted over 200,000 applications from people willing to leave Earth forever. They raised tens of millions of dollars, and in 2019, they went bankrupt, having never sent a single piece of hardware to space. The MIT researchers who analyzed Mars One's technical plans found problems that went beyond optimistic timelines. The life support system, as designed, would have killed the astronauts in 68 days. Not from some exotic Mars hazard, but from basic atmospheric management. Following fire safety standards meant the system would over-oxygenate the habitat, requiring excessive nitrogen to compensate. The nitrogen supplies would run out, pressure would drop, and the astronauts would die. Mars One claimed 6 Falcon Heavy rockets could deliver the needed supplies. MIT's analysis said 15 would be required, pushing transportation costs to $4.5 billion just for initial cargo. And that was before the astronauts even launched. The project collapsed under the weight of its own technical impossibilities. But Mars One's failure reveals something crucial. The gap between what sounds plausible in a press release and what's actually achievable with current technology is vast. And that gap gets wider when you're not just trying to land on Mars, but trying to leave it again. The energy requirements tell the story clearly. A round trip to Mars requires more than double the energy of a one-way mission. You need enough energy to climb out of Mars's gravity well, push the spacecraft and crew back across interplanetary space, and capture into Earth orbit. Then you need to survive re-entry at velocities between 47,000 and 54,000 kilometers per hour, compared to Apollo 11's already extreme 40,000 kilometers per hour re-entry. The propellant mass alone is staggering. At least 1,200 metric tons of propellant for the return journey. That would require at least 5 starships to Mars, which means at least 60 heavy lift launches from Earth just to support a single return mission. Each of those launches costs tens of millions of dollars at minimum. Each represents thousands of things that could go wrong. Each adds complexity to a mission profile that's already pushing the boundaries of what's possible. Chris Kraft, NASA's first flight director, estimated that providing return capability makes Mars missions 10 times more expensive than one-way trips. Buzz Aldrin's estimate is more conservative, suggesting 3 to 4 times more expensive. Even taking the lower estimate, you're looking at the difference between a barely achievable mission and one that might require funding that no nation or company can sustain. This is why serious proposals for Mars settlement increasingly drop the pretense of near-term return capability. The math doesn't work, the engineering doesn't work, the economics definitely don't work, but there's something even more fundamental that makes return missions questionable, something that doesn't show up in engineering schematics or budget spreadsheets. The human body isn't designed for Mars, and the longer you stay there, the less capable you become of surviving anywhere else. During the journey to Mars, astronauts would spend 200 to 350 days in microgravity. Their bones would lose roughly 1% of their density per month. Their muscles would atrophy despite 2 hours of daily exercise. Their cardiovascular systems would decondition, adapting to an environment where pumping blood doesn't require fighting gravity. Then they'd arrive on Mars, where gravity is 1/3 of Earth's. Not microgravity, but not enough to prevent continued physiological degradation. Research suggests that partial gravity below 0.4 g is insufficient to maintain musculoskeletal and cardiopulmonary conditioning long-term. Mars at 0.38 g falls just below that threshold. Studies of astronauts returning from 6-month stays on the International Space Station show arterial and endocrine damage consistent with over a decade of aging. And that's after 6 months in microgravity, followed by immediate return to Earth's 1G environment. A Mars mission would mean up to 300 days in microgravity getting there, potentially 500 days in 0.38 g on the surface, then another 300 days in microgravity coming back. 3 years total, most of it in reduced gravity. The human body would adapt to these conditions. That's what bodies do. They optimize for their environment. Bones would thin because dense bones aren't needed when you weigh 1/3 of your Earth weight. Muscles would shrink because maintaining muscle mass in low gravity is metabolically expensive and provides no survival advantage. The cardiovascular system would adjust to the reduced demands of pumping blood in weak gravity. These adaptations make perfect sense for surviving on Mars. They're disastrous for returning to Earth. Imagine spending 3 years becoming perfectly adapted to Martian conditions, then stepping back into Earth's gravity. Your skeleton, now optimized for 1/3 G, would suddenly need to support 3 times the weight it's been carrying. Your heart, recalibrated for pumping blood in low gravity, would struggle to prevent blood from pooling in your legs. Your muscles, atrophied from years of reduced demand, would strain to move a body that feels 3 times heavier than it did when you left. This isn't speculation about unknown effects. Astronauts returning from the ISS sometimes can't stand without assistance. They experience orthostatic intolerance, meaning their cardiovascular system can't maintain blood pressure when they stand up. Some can't walk for days, and that's after 6 months in microgravity, followed by intensive rehabilitation. Now triple the duration. Add the complication of partial gravity adaptation. Remove the possibility of immediate medical intervention because you're landing after a 7-month journey, during which your body experienced yet more microgravity deconditioning. Current countermeasures don't fully solve this problem. Exercise helps, but doesn't prevent bone loss entirely. Bisphosphonate drugs reduce the rate of bone density loss, but don't eliminate it. Centrifuge training has been proposed, but never tested for multi-year durations. And none of these address the fundamental issue. The human body adapts to its environment, and after years on Mars, Earth becomes the alien environment. There's another factor that makes this worse. The longer you stay on Mars, the longer your return journey needs to be postponed. Launch windows between Earth and Mars only open every 26 months when the planets align favorably in their orbits. Miss your window and you're waiting over 2 years for the next one. Imagine you're on Mars, your return vehicle is fueled and ready, and something goes wrong. Equipment fails. Someone gets injured. A dust storm damages your solar panels. Suddenly, you're not leaving during this launch window. You're staying for another 26 months minimum, during which your body continues adapting to Martian gravity. Your supplies continue depleting, and your equipment continues aging in an environment that destroys everything through dust infiltration, temperature cycling, and radiation exposure. And speaking of radiation, that's yet another reason the first Mars cruise might never make it home. But the radiation problem is so severe, so fundamental to the impossibility of safe Mars missions, that it deserves its own examination. What we've covered so far are the engineering and biological challenges of return missions, the fuel that might not exist, the bodies that might not survive the journey home. But there's a darker element to this story, one that space agencies acknowledge in technical papers while downplaying in public statements. The radiation environment between Earth and Mars, and on the Martian surface itself, might make the entire discussion of return missions irrelevant, because the astronauts might not survive long enough for return to be an option. The radiation begins the moment you leave Earth's protective embrace. Our planet's magnetic field acts like an invisible shield, deflecting most of the charged particles streaming from the sun and cosmic rays arriving from deep space. Step outside that protection and you're exposed to radiation levels that would be illegal for nuclear power plant workers to experience even for a single shift. During the 7-month journey to Mars, astronauts would absorb roughly 60% of the total radiation dose NASA considers safe for their entire career. That's before they even arrive, before they spend a single day on the Martian surface, before the return journey that would double their exposure. The numbers are stark. A single day in deep space delivers the same radiation dose you'd receive in an entire year on Earth's surface. An astronaut on a Mars mission could face radiation levels 700 times higher than what we experience under our protective atmosphere and magnetic field. The Mars Radiation Environment Experiment confirmed that radiation in orbit above Mars runs 2.5 times higher than at the International Space Station, and the Martian surface itself offers almost no protection. Why is Mars so vulnerable? The planet lost its magnetic field billions of years ago when its core cooled and stopped generating the dynamo effect that creates protective magnetospheres. Without that shield, and with an atmosphere just 1% as thick as Earth's, radiation pours onto the surface unimpeded. Solar particle events, galactic cosmic rays, secondary radiation created when cosmic rays strike the Martian soil. All of it reaches the surface where humans would be trying to live. Current spacecraft offer minimal protection. Aluminum hulls actually make certain types of radiation worse through a process called spallation, where cosmic rays strike the metal and create secondary particle showers that can be more damaging than the original radiation. Water provides better shielding, but you'd need several feet of it surrounding the entire crew compartment, adding impossible mass to an already weight-constrained mission. Some proposals suggest building habitats underground or covering them with Martian regolith for shielding. That helps for surface operations, but does nothing for the 14-month journey through space. And it assumes you can actually excavate or move enough Martian soil to create effective shielding, which requires heavy equipment, power systems, and time that early missions won't have. The biological effects extend far beyond cancer risk, though that alone should give us pause. A 3-year Mars mission would exceed NASA's current safety limits and double the previously estimated cancer risk. But radiation damages more than DNA. It affects the cardiovascular system, potentially accelerating atherosclerosis and heart disease. It degrades the central nervous system, impacting cognitive function, memory, and decision-making. Studies on mice exposed to radiation similar to what Mars astronauts would experience showed persistent cognitive impairment lasting months after exposure ended. The brain damage is particularly concerning. Cosmic rays can destroy neurons and disrupt neural connections, leading to problems with learning, memory, and executive function. Imagine trying to operate complex equipment, make critical decisions, or respond to emergencies while your cognitive abilities are degrading from accumulated radiation exposure. Now imagine this happening millions of miles from any possible help. There's no good solution to the radiation problem with current technology. Faster propulsion systems would reduce transit time and therefore exposure, but we don't have engines capable of cutting the journey from months to weeks. Pharmaceutical countermeasures are being researched, but nothing has proven effective against the range of radiation types astronauts would face. Antioxidants might reduce some damage, but they can't prevent it entirely. Some researchers propose using the spacecraft's water supply and food stores as improvised shielding, arranging them around a central storm shelter where the crew could retreat during solar particle events. This might protect against sudden solar storms, but does nothing about the constant background exposure to galactic cosmic rays that no amount of rearranging supplies will stop. The return journey presents a nightmare scenario. After spending a year or more on Mars absorbing surface radiation, astronauts would face another 7 months of deep space exposure on the way home. By the time they reached Earth, they would have accumulated radiation doses far beyond what's considered safe, with health effects that might not manifest for years or decades. And here's something most people don't realize. The radiation damage is cumulative and irreversible. You can't undo it with treatment once you're back on Earth. The DNA damage, the cardiovascular degradation, the neural impairment, these are permanent consequences of the exposure. Some effects might be managed with medical intervention, but the fundamental damage remains. This creates an ethical question that space agencies don't like to discuss publicly. Is it acceptable to send people on a mission knowing they'll receive radiation exposure that will likely shorten their lives and increase their risk of serious diseases? NASA's current radiation limits exist because we've decided certain exposure levels are too dangerous to accept. A Mars mission would blow past those limits. The agencies have started quietly revising their risk assessment models, essentially moving the goalposts to make Mars missions appear more feasible. Instead of limiting total career exposure, they're talking about acceptable risk and comparing it to other dangerous professions. It's a calculated shift in how we think about astronaut safety, making radiation exposure a choice astronauts make rather than a limit mission planners must respect. But there's a difference between accepting calculated risk and accepting near certain harm. Fighter pilots face danger, but we don't send them on missions knowing their aircraft will definitely crash. Astronauts on the ISS face risks, but we've engineered the station to keep those risks as low as possible. A Mars mission with current technology doesn't minimize radiation risk. It guarantees exposure to dangerous levels. The psychological impact compounds the physical danger. Imagine living for years knowing that invisible radiation is damaging your body at the cellular level. You can't see it, can't feel it, can't do anything to stop it. Every day on Mars, every moment of the journey home, you're accumulating damage that will affect the rest of your life, however long that might be. Some astronauts might accept this risk willingly, understanding the consequences and choosing to go anyway. But acceptance doesn't change the physics. It doesn't make the radiation less dangerous or the mission more survivable. It just means people are willing to sacrifice their health and potentially their lives for the goal of reaching Mars. The radiation problem intersects with everything else we've discussed. The longer you stay on Mars because you can't produce fuel fast enough, the more radiation you absorb. The more launch windows you miss due to equipment failures, the more exposure accumulates. The physiological adaptations to Martian gravity that make return difficult happen while your body is simultaneously being degraded by radiation, creating a cascade of health problems that interact in ways we can't fully predict. Current research uses animal studies and simulations to estimate effects, but we've never actually exposed humans to the full spectrum of radiation they'd face on a Mars mission. The astronauts who go will be test subjects in an experiment we can't fully design because we don't know all the variables. They'll discover the real effects of long-duration deep space radiation exposure by experiencing them firsthand. There's also the question of acute radiation events. Solar particle storms can arrive with little warning, releasing bursts of radiation that could be lethal without adequate shielding. On Earth, our magnetic field deflects most of this. On Mars, with no magnetic protection and minimal atmospheric shielding, a major solar storm could deliver a fatal dose to anyone caught outside a heavily shielded habitat. The spacecraft traveling between planets would be even more vulnerable. Monitoring solar activity helps predict some storms, but not all of them, and predictions are imperfect. You might get a few hours warning, enough to seek shelter if you're near your habitat. But what if you're halfway through a multi-day expedition across the Martian surface? What if the storm hits while you're in transit between planets with nowhere to hide? These aren't theoretical concerns. Solar particle events happen regularly. We've just never had humans in an environment where such events could be lethal. The Apollo astronauts were lucky. A major solar storm occurred between Apollo 16 and 17. If it had hit during a lunar surface mission, the astronauts could have received a fatal radiation dose. Mars missions last year's, not days, dramatically increasing the odds of encountering a dangerous solar event. The radiation problem doesn't have a solution with current technology. It has mitigation strategies that reduce exposure from catastrophic to merely dangerous. That's not the same thing. We're talking about sending people into an environment that will definitely harm them, hoping the harm isn't severe enough to kill them or leave them unable to function. This is the reality that makes discussions of return missions almost beside the point. You can solve the fuel production problem with enough engineering effort and resources. You can potentially address some of the physiological adaptation issues with countermeasures and rehabilitation, but you can't shield astronauts from radiation during multi-year missions. Without fundamentally different spacecraft designs or propulsion systems we don't have. The first Mars crews will absorb radiation doses that would be criminal to expose workers to in any other context. They'll return to Earth, if they return at all, with damaged DNA, increased cancer risk, degraded cardiovascular systems, and potential cognitive impairment. These aren't possibilities or worst-case scenarios. These are the expected, probable consequences of current mission designs. And we haven't even addressed what might be the most insurmountable obstacle to Mars exploration. The psychological challenges of spending years in an environment where every mistake could be fatal, where rescue is impossible, and where the isolation exceeds anything humans have ever experienced. That's where the mission might truly break down, not in the hardware or the biology, but in the human mind trying to cope with conditions we didn't evolve to handle. The isolation alone would test the limits of human psychology in ways we can barely predict. You're trapped in a small habitat with the same handful of people for years, knowing that the nearest other humans are on a planet that's never closer than 34 million miles away. Earth is a light in the sky, nothing more. The communication delay ranges from 4 to 24 minutes one way, depending on where the planets are in their orbits. You can't have a conversation. You can't call home when you're having a bad day. Every message is a time capsule sent across the void, with no guarantee anyone will respond in a time frame that matters. Think about that for a second. You send a message asking for help with a critical decision. Best case scenario, you're waiting 8 minutes for a response. More likely, you're waiting 48 minutes for someone on Earth to even know you asked a question. If you're facing an emergency, you're on your own. Mission Control can't save you. They can't even talk you through the problem in real time. By the time they know something's gone wrong, you've either fixed it or you're dead. The psychological studies we've done on isolation are laughably inadequate compared to what Mars crews will face. Antarctic winter-over crews, submarine crews, ISS astronauts, none of them are truly isolated. Help could reach Antarctic stations within days if absolutely necessary. Submarines can surface. ISS astronauts can be home in hours. Mars has no escape hatch, no emergency extraction, no possibility of rescue. You're looking at a minimum mission duration of around 3 years even for the shortest possible stay. That's assuming everything goes perfectly, which it won't. More realistic estimates push closer to 4 years. 4 years in an artificial environment smaller than most houses, with the same few people, eating preserved food, breathing recycled air, drinking water reclaimed from your own waste, unable to go outside without a spacesuit, with nothing but rock and dust in every direction to the horizon. The monotony would be crushing. Mars has weather, but it's subtle. Dust storms, yes, but mostly it's just variations in wind and temperature that you'd barely notice from inside a habitat. No rain, no snow, no seasons in any meaningful sense. The sky is butterscotch during the day, deep blue at sunset, black at night. That's it, every day, for years. Research on sensory deprivation and environmental monotony shows measurable cognitive decline with far less extreme isolation than Mars missions involve. Attention span degrades. Decision-making ability suffers. Emotional regulation becomes difficult. And that's in controlled studies, with the knowledge that it's temporary and help is available. Now add the constant background stress. Every system in your habitat is critical. The air recycling system fails, you suffocate. Water recycling fails, you die of dehydration within days. Power systems fail during the Martian winter, you freeze. Radiation shielding develops a gap. You're exposed to potentially lethal doses. Agricultural systems fail, you starve. Any of these failures could be fatal, and you're the only people who can fix them. You'd be living in a state of permanent low-level emergency response, always monitoring systems, always aware that your survival depends on technology, continuing to function in an environment it wasn't designed for. That kind of chronic stress does terrible things to human psychology over time. Anxiety disorders, depression, paranoia, and the normal coping mechanisms people use. Going for a walk, seeing friends, changing your environment. None of those exist. The crew selection process tries to screen for psychological resilience, but we have no real baseline for who can handle this. The people who've spent the longest in space, the cosmonauts who lived on Mir for over a year, were still in low Earth orbit with Earth visible outside the window and regular supply ships arriving. Mars crews won't have those psychological anchors. Earth will be a dot. Supply ships will arrive every 2 years if they arrive at all. Then there's the group dynamic problem. You can't just throw compatible people together and expect them to function perfectly for years under extreme stress. Conflicts will develop. Personalities will clash. Romantic entanglements will complicate matters. Leadership disputes will emerge. In any small, isolated group, tensions build over time. But on Earth, people in conflict can separate, can leave, can bring in outside help to mediate. None of those options exist on Mars. One serious personality conflict could compromise the entire mission. One person who develops a psychological crisis could endanger everyone else. And there's no replacement crew, no ability to remove someone who's become a problem. You're stuck with whoever you launched with, regardless of how relationships evolve or deteriorate. Studies of analog Mars missions, where crews spend extended periods in isolated habitats on Earth, consistently show psychological stress as one of the biggest challenges. And those studies have escape hatches. Participants know they can leave if things get truly unbearable. They know rescue is possible. Mars crews won't have that psychological safety net. The knowledge that you're truly on your own, that no one can extract you even if you desperately want to leave, creates a completely different psychological dynamic. Some researchers worry about what's called the third quarter phenomenon, where morale crashes hardest not at the beginning or end of an isolated mission, but somewhere around the 3-quarter mark. You've been there long enough that the novelty has worn off completely, but you're not close enough to the end to start anticipating release. For a 4-year Mars mission, that's around the 3-year mark. Right when the crew needs to be at peak performance preparing for departure, they're statistically most likely to be experiencing their lowest morale and highest stress levels. And we haven't even addressed what happens if someone dies, not from an accident, but from illness or the cumulative effects of radiation exposure. What do you do with the body? How does the surviving crew cope with that psychological trauma while still having to maintain all the systems that keep them alive? There's no grief counselor, no funeral, no opportunity to process the loss in any normal way. You keep working because stopping means dying. The physical isolation translates to informational isolation too. Yes, you can receive data from Earth, but it's always going to be hours or days out of date. News about family emergencies arrives too late to matter. If a loved one dies, you learn about it after the funeral has already happened. You can't be there. You can't help. You can only receive delayed messages about events you're powerless to influence. That sense of helplessness extends to everything. Political changes on Earth that affect your mission's funding and support, natural disasters affecting your family, personal crises among people you care about. You're informed but impotent, watching recorded messages about things that have already happened that you had no ability to affect. That kind of enforced passivity regarding everything outside your immediate environment creates its own psychological strain. Some mission planners suggest sending carefully curated entertainment, news, and communication to maintain psychological health. But what do you send? How do you keep people engaged with a world they're no longer part of and may never return to? Do you tell them about problems on Earth they can't help with? Do you shield them from bad news, creating an artificial bubble that makes their eventual return even more jarring if return is possible? The psychological challenges don't exist in isolation from the physical ones. They compound. You're not just dealing with isolation and monotony. You're dealing with isolation and monotony while your body is deteriorating from reduced gravity and radiation exposure, while eating a restricted diet, while breathing recycled air, while knowing that you're physically changing in ways that might make return to Earth impossible. Sleep disruption is almost guaranteed. The Martian day is about 40 minutes longer than Earth's, which doesn't sound like much, but is enough to gradually desynchronize circadian rhythms. Studies on Earth show that even small circadian disruptions lead to mood disorders, cognitive impairment, and physical health problems. Now combine that with the stress, the isolation, the confined environment, and the physical effects of partial gravity and radiation. You'd need an enormous amount of meaningful work to stay psychologically healthy. Boredom might be as dangerous as any technical failure, but the work itself creates stress. Every task carries high stakes. You can't afford mistakes. There's no room for error. That combination of needing to stay busy to maintain mental health, but having every task be potentially life or death creates a psychological pressure cooker. And here's something that doesn't get discussed enough. What if someone just gives up? What if the psychological burden becomes too much and a crew member decides they're done? In that small, confined space with limited resources and no escape, one person checking out mentally could cascade into a mission-ending crisis. You can't force someone to want to survive. You can't force them to maintain systems or participate in mission-critical activities, but their non-participation directly threatens everyone else. Mission planners know all of this. The psychological challenges aren't a surprise, but the proposed solutions are mostly theoretical. Virtual reality to provide environmental variety and psychological escape. Carefully structured schedules to provide routine and purpose. Extensive pre-mission training in conflict resolution and stress management. Support from Earth-based psychologists despite the communication delay. None of these solutions have been tested in anything approaching actual Mars mission conditions. We're essentially planning to run a massive psychological experiment using human subjects who volunteered for something they can't truly understand until they're already committed. The consent might be informed in theory, but no one can really know how they'll respond to years of isolation on Mars until they're actually there. This brings us back to the question of return. Even if we solve the technical challenges of producing fuel on Mars, even if we develop better radiation shielding, even if we find ways to counteract the physiological effects of partial gravity, we're still sending people into a psychological meat grinder that might break them in ways that make return impossible, even if the physical capability exists. What if a crew makes it to Mars, survives the surface stay, and then simply refuses to attempt the return journey because they can't face months more in a cramped spacecraft? What if the psychological deterioration is severe enough that they're no longer capable of operating the complex systems required for the return trip? You can't operate a spacecraft safely if your crew is suffering from severe depression, anxiety disorders, or decision-making impairment from chronic stress. The people who go to Mars first will be pioneers in every sense, including psychological pioneers exploring the limits of what human minds can endure. Some of them might adapt. Humans are remarkably resilient when necessary. But resilience has limits, and we're planning to test those limits in an environment where failure means death, not just for individuals, but potentially for entire crews. And all of this assumes the mission goes relatively smoothly. No major equipment failures, no unexpected medical emergencies, no critical supplies running out sooner than planned. Add any serious complications to the baseline psychological stress, and you're looking at scenarios where the crew's mental state becomes as much a threat to mission success as any technical failure. The harsh truth is that the psychological challenges of Mars missions might be fundamentally unsolvable with current approaches. We can't change human psychology. We can't eliminate the basic need for social connection, environmental variety, and sense of purpose. We can't train away the stress response to constant danger and isolation. We can only hope that the people we send are resilient enough to endure what we're asking of them. But even that hope rests on assumptions about human adaptability that haven't been tested in conditions anything like a Mars mission. We're making educated guesses about psychological limits based on data from situations that aren't really comparable. And the cost of being wrong isn't just a failed mission. It's human lives and sanity. The first Mars crews will be test subjects in a psychological experiment we can't ethically run on Earth. They'll discover through direct experience whether humans can maintain mental health and functional cognition during multi-year isolation in a hostile environment. Some of them probably can. Some of them probably can't. We won't know which until they're already there, already committed, already facing consequences they can't escape from. And this psychological reality creates a cascading problem that mission planners desperately want to ignore. Because once you've sent humans to Mars who are psychologically compromised, you haven't just lost those individuals. You've potentially contaminated the entire mission concept for a generation. Think about what happens when the first Mars crew comes back broken. Not dead. Broken. When they return to Earth after spending years on Mars and months more in transit, and they can't readjust to normal life. When they're suffering from PTSD so severe they can't function in society. When the isolation and stress have left permanent psychological scars that no amount of therapy can fully heal. The media coverage would be devastating. Every news outlet would run stories about the psychological casualties of Mars exploration. Public opinion would turn sharply against sending more missions. Politicians would face enormous pressure to cancel future programs. And the pool of qualified candidates willing to volunteer would evaporate overnight. Nobody wants to be the second crew when the first crew came back traumatized. This is why some mission architects have quietly started discussing whether the first Mars missions should simply be one-way trips from the beginning. Not because of the technical challenges we've discussed, though those are real enough, but because the psychological damage might be so severe that attempting to bring people back would actually be crueler than leaving them there. At least on Mars, they'd have a purpose. They'd be building something. They'd have the mission to focus on. Bring them back to Earth. And what do they have? Memories of trauma, bodies broken by low gravity and radiation, minds scarred by isolation, and a planet full of people who can never understand what they experienced. The Mars to Stay concept has been floating around space policy circles for years. Buzz Aldrin himself has advocated for it, comparing Mars settlement to the Pilgrims on the Mayflower. They didn't sit around Plymouth Rock waiting for a return trip. When you go to Mars, you need to have made the decision that you're there permanently. The economics support this approach. One-way missions would be 3 to 4 times less expensive than round-trip missions according to Aldrin's estimates. Other analysts like Chris Kraft have suggested the cost difference could be even more dramatic, potentially 10 times more expensive to provide return capability. Much of that expense lies in launching to Mars a return spacecraft and all the propellant needed for the months-long flight back to Earth. But there's a more fundamental argument beyond cost. The health risk of extended space travel is high, significantly increasing the probability for cancer and other radiation-induced diseases. A one-way trip poses only half the radiation risk of a return mission. You're only subjecting the crew to 1 long-duration transit instead of 2. From a purely utilitarian perspective, it makes sense. Send people to Mars to stay, establish a permanent settlement, keep sending supplies and new crew members every launch window. Build something lasting rather than conducting brief visits that accomplish little beyond demonstrating we can get there and back. The problem is that this logic only works if you ignore the human element entirely. Because calling it a one-way mission sounds noble and pioneering until you think about what it actually means. You're asking people to volunteer for exile, permanent separation from everything and everyone they've ever known, a life sentence on a hostile world where a single equipment failure could kill them and where rescue is impossible. And here's the thing that makes this especially dark. The people most likely to volunteer for such a mission are probably the people least psychologically suited for it. Think about who signs up for a one-way trip to Mars. You'd get some genuinely dedicated scientists and engineers, sure. People who truly believe in the mission and are willing to sacrifice everything for it. But you'd also get people running from something. People with nothing to lose. People whose judgment about risk and consequence might not be entirely sound. The selection process would be a nightmare. How do you screen for psychological suitability when the mission itself is psychologically extreme? How do you identify people who can handle permanent isolation when nobody has ever actually experienced permanent isolation on another planet? You'd be making educated guesses, hoping that the psychological profiles and testing you conduct on Earth translate to Mars. But there's no way to truly know until they're already there, already committed, already facing the reality that they'll never leave. Mars One tried this approach. You remember Mars One, the Dutch company that announced plans to send people to Mars for permanent settlement, accepting the fact that return wouldn't be possible. They received over 200,000 applications, 200,000 people willing to volunteer for a one-way trip to Mars. The company selected candidates, ran them through preliminary screening, made big announcements about their revolutionary approach to Mars colonization. Then reality intervened. MIT researchers analyzed the Mars One plan and found it fundamentally flawed. The environmental system would fail to support human life within 68 days if fire safety standards were followed. The excessive use of nitrogen supplies would lead to loss of pressurization, ending with cabin pressures too low to support human life. The company needed 15 Falcon Heavy rockets just for initial supplies instead of the 6 they'd planned for. Transportation costs alone would be $4.5 billion. And they had no realistic funding model to support any of this. Mars One went bankrupt in 2019. The whole project collapsed. And what became of those 200,000 applicants who'd been willing to die on Mars? They learned that volunteering for a one-way mission doesn't make the mission viable. Enthusiasm doesn't replace engineering. Willingness to sacrifice doesn't overcome physics. But the Mars One failure teaches us something crucial about the psychology of one-way Mars missions. Those applicants weren't stupid or suicidal. Many were highly educated, thoughtful people who genuinely considered what they were volunteering for, and they were still willing to go. That tells us something about human nature. Some people genuinely would choose Mars even knowing it's permanent. The question is whether those people are making a rational choice, or whether they're driven by psychological factors that would make them poor candidates for the mission. Because here's what nobody wants to say out loud. The overlap between people willing to volunteer for permanent exile on Mars and people psychologically stable enough to survive permanent exile on Mars might be smaller than we'd like to think. The most stable, well-adjusted individuals tend to have strong connections to life on Earth. Family, friends, careers, hobbies, communities. They have reasons to want to come back. The people with the fewest ties to Earth, the ones most willing to never return, are often the ones who've struggled to build those connections in the first place. And struggling to build connections on Earth doesn't suggest you'll suddenly thrive in the isolated environment of a Mars base. This creates a selection paradox. You need people psychologically resilient enough to handle isolation, but those people are usually the ones least willing to volunteer for permanent isolation. The people most willing to go might be the ones least capable of handling what they're volunteering for. Mission planners would have to navigate this carefully. Screen for resilience while acknowledging that perfect candidates might not exist. Accept some psychological risk while trying to minimize the most dangerous factors. Build in support systems knowing they'll be inadequate. And they'd have to live with the knowledge that they're conducting an experiment with human lives. Sending people into a situation we can't fully predict, hoping our screening was good enough, knowing that failures will be permanent and visible. Now add in the complications we haven't even touched on yet. Medical emergencies that can't be treated with the limited facilities on Mars. Equipment failures that can't be repaired without parts from Earth. Supply shipments that get delayed or fail to arrive. interpersonal conflicts that escalate in the pressure cooker environment. Every problem on Mars is amplified by isolation. Every challenge becomes potentially mission critical. And the psychological toll of dealing with crisis after crisis without any hope of escape or relief would be crushing. You can't call in sick on Mars. You can't take a vacation. You can't step outside for fresh air. You can't quit and go home. You're there, committed, facing whatever comes until you die. That's the reality of a one-way Mars mission. Not the romantic vision of pioneering a new world, but the grinding daily struggle to survive in an environment that's actively trying to kill you, with no rescue coming, ever. And this brings us back to the question of return, because even if we could solve the technical challenges, even if we could produce fuel on Mars and maintain spacecraft for years and overcome all the engineering obstacles, we'd still face this fundamental question. Would the people we send to Mars even be capable of making the return journey? After years of psychological stress, physiological degradation, and adaptation to Martian conditions, would they have the mental and physical capacity to operate a complex spacecraft for months through deep space? Would they be able to handle the additional stress of the return transit? Would they survive re-entry and landing on Earth? Or would we bring back people so damaged by their Mars experience that their return becomes a cautionary tale that ends human Mars exploration for generations? The engineers can work on the technical problems. They can design better radiation shielding, develop more efficient fuel production systems, create spacecraft capable of the journey. Those are hard problems, but they're solvable with enough time and money. The human problems might not be solvable at all. You can't engineer away the psychological impact of isolation. You can't design around the physiological effects of low gravity and radiation. You can't eliminate the fundamental reality that Mars is hostile to human life in ways that create cumulative damage over time. Every day on Mars makes returning to Earth harder. Every month of exposure to radiation increases cancer risk. Every year in low gravity weakens bones and muscles and cardiovascular systems. The longer someone stays on Mars, the less capable they become of surviving the return journey. This creates a closing window. Early in a Mars mission, return might be possible if challenging. But as time passes and damage accumulates, the window closes. Eventually, return becomes physically impossible, even if all the technical systems work perfectly. How long is that window? Nobody knows for sure. We don't have enough data on long-term low-gravity exposure. We don't fully understand the cumulative effects of Mars radiation. We can make estimates based on what we know from the ISS and from radiation studies, but Mars is different enough that our estimates could be wildly wrong. What we do know is that the window exists and it closes. Send people to Mars, and there's a point of no return that has nothing to do with fuel or spacecraft or launch windows. It's a physiological point of no return, where their bodies have adapted to Mars in ways that make Earth unsurvivable. Cross that threshold, and return stops being an option regardless of the engineering. The mission becomes one way, not by choice or design, but by biological inevitability. This is where the conversation shifts from technical challenges to something darker. Because there's another possibility we haven't fully explored yet. What if the first Mars mission isn't designed to bring people back? What if, from the very beginning, we're planning to send humans on a one-way trip? This isn't science fiction speculation. It's been seriously proposed by respected figures in the space community. Buzz Aldrin, the second person to walk on the moon, has publicly advocated for one-way Mars missions. He compared it to the Pilgrims sailing to America on the Mayflower. They didn't sit around Plymouth Rock waiting for a return ship. They came to stay. According to Aldrin, when you go to Mars, you need to have made the decision that you're there permanently. The economic argument is compelling. Aldrin estimated that one-way missions would be 3 or 4 times less expensive than round-trip missions. Chris Kraft, NASA's first flight director, put the difference even higher, suggesting return capability makes missions 10 times more costly. Much of that expense comes from launching a return spacecraft and all the propellant needed for the months-long flight back to Earth. But the rationale extends beyond simple cost savings. The health risks of extended space travel are significant. A one-way trip exposes astronauts to only half the radiation of a return mission. You're cutting the time spent in deep space in half. From a purely medical standpoint, it reduces cancer risk and other radiation-related health problems. In 1998, space activist Bruce Mackenzie presented a paper at the International Space Development Conference titled "One Way to Mars: A Permanent Settlement on the First Mission." His argument was straightforward. We could establish a permanent Mars settlement with less difficulty and expense than a round-trip mission. Just send people with the supplies and equipment needed to survive indefinitely. This concept gained enough traction that an organization called Mars One formed to actually attempt it. Mars One was a private Dutch company that planned to land the first humans on Mars and leave them there to establish a permanent colony. They proposed sending a communication satellite and Pathfinder lander by 2018, then landing 4 humans on Mars for permanent settlement in 2027, with new groups of 4 arriving every 2 years after that. The response was stunning. Mars One received over 200,000 applications from people willing to leave Earth forever. 200,000 people volunteered for a one-way ticket to die on Mars. That number deserves consideration. What does it say about humanity that so many people were willing to abandon Earth permanently for the chance to be among the first on another planet? But Mars One fell apart, exactly as you'd expect. The technical and financial problems proved insurmountable. According to their plan, 6 Falcon Heavy rockets would send initial supplies. MIT researchers analyzed the proposal and determined they'd actually need 15 Falcon Heavy rockets, with transportation costs alone reaching $4.5 billion just for supplies and the astronaut launch. Then there were the life support issues. MIT identified critical failures in the environmental system. If they followed fire safety standards on over-oxygenation, the system would fail to support human life within 68 days. The excessive use of nitrogen supplies would lead to loss of pressurization, ending with pressures too low to sustain life. The people Mars One planned to send would suffocate in their habitat before they'd been on Mars for 3 months. By 2016, Mars One ran out of funds and couldn't continue selection or technical studies. Several attempts to raise additional funding failed. In early 2019, the company declared bankruptcy. The dream of a privately funded, one-way Mars colony died quietly, leaving behind a cautionary tale about the gap between ambition and reality. Yet the concept itself refuses to die. Because despite Mars One's failure, the fundamental logic remains. Return missions are monumentally expensive and technically complex. One-way missions are comparatively simpler and cheaper. If we're serious about establishing a human presence on Mars, rather than just planting a flag and leaving, doesn't it make more sense to send people who plan to stay? This is where we enter ethically murky territory. Is it acceptable to send people on a mission where return is impossible? Can we morally justify asking astronauts to commit to dying on another planet? Where do we draw the line between exploration and exploitation? Some argue that as long as volunteers understand the risks and accept them willingly, there's no ethical problem. Adults have the right to make dangerous choices. People climb mountains knowing they might die. Deep-sea divers accept risks. Test pilots volunteer for experimental aircraft. Why should space exploration be different? But there's a qualitative difference between accepting risk and accepting certainty. Climbers might die on Everest, but they're not guaranteed to die there. Most make it back. With a one-way Mars mission, death on Mars isn't a risk you're accepting. It's the outcome you're guaranteeing. You're not signing up for a dangerous journey with a chance of death. You're signing up for death on an alien world with a few years of exploration beforehand. The psychological screening for such a mission would be unlike anything we've attempted. How do you identify people psychologically stable enough to function effectively in extreme isolation, while also willing to never see Earth again? Those two criteria might be mutually exclusive. The personality traits that make someone suitable for long-duration space missions, stability, emotional regulation, ability to work in teams, might be incompatible with the mindset needed to accept permanent exile. You'd need people detached enough from Earth that leaving forever doesn't devastate them, but attached enough to their mission and crew that they remain motivated to survive and work effectively. That's a narrow psychological profile. Finding even 4 people who fit it would be challenging. Finding the dozens needed for a sustainable colony might be impossible. Then there's the question of what happens when things go wrong. And things will go wrong. Equipment fails. People get sick. Accidents happen. On Earth, or even on the ISS or a moon base, you can evacuate. Medical emergencies can be treated back home. Critical equipment failures can be addressed with supply missions. But on a one-way Mars mission, every problem becomes potentially fatal with no backup plan. Imagine you're part of the first permanent Mars crew. 6 months into the mission, your life support system develops a fault that can't be repaired with available materials. You know, with certainty that you have maybe a year before it fails completely. There's no rescue coming, no supply ship with replacement parts, no possibility of evacuation. You just wait to die, watching the countdown, knowing exactly when your air or water or heat will run out. Or consider medical emergencies. Appendicitis, which is easily treatable on Earth, becomes a death sentence. A broken bone that becomes infected might kill you. Cancer, which might be cured with treatment back home, becomes terminal. Every medical condition is potentially fatal because you don't have access to the full range of human medical knowledge and equipment. You have what you brought and nothing more. The psychological impact of this isolation would be profound. Astronauts on the ISS know they can come home. Even on a round-trip Mars mission, there's an end date, a return to Earth to look forward to. But on a one-way mission, every day you wake up knowing you'll die on Mars. Your bones will be buried in Martian soil. Nobody will ever visit your grave except your fellow colonists. And eventually they'll die too, and the whole settlement might be forgotten. A failed experiment on a dead world. Communication delays make it worse. When you talk to people on Earth, there's a 20-minute delay each way. Conversations become exchanges of recorded messages. You can't have a real-time discussion with anyone you left behind. You'll watch your family age in time-delayed video messages. You'll see your parents grow old and die. Your siblings have children. Your friends move on with their lives, all through recordings that arrive hours after they were sent, and the messages will become less frequent over time. People back home will move on. Your life becomes increasingly irrelevant to Earth. You're a curiosity maybe, someone who sends occasional updates from Mars, but you're not part of their world anymore. You're cut off, separated not just by distance, but by the fundamental reality that you exist in a different context now. You're not human in the same way. You're a Martian, whatever that means, living a life that nobody on Earth can truly understand. The question of children adds another layer of complexity. Should colonists be allowed to have children on Mars? Those children would be born into an environment that would prevent them from ever visiting Earth. They'd grow up in low gravity, exposed to high radiation, adapted to conditions that make Earth uninhabitable for them. They'd be human, but not earthly, a new branch of humanity that can never return to the homeworld. Is it ethical to create humans who are born into permanent exile, who never have the choice their parents had? The colonists volunteered for a one-way trip, but their children didn't volunteer for anything. They'd be born into circumstances that define and limit their entire existence. Some might argue this is no different from any birth. None of us choose our circumstances. We're all born into situations we didn't select. But there's a difference between being born into difficult circumstances on Earth and being born on a planet where the atmosphere is poison, the radiation is deadly, and the environment requires technological life support systems just to breathe. A child born on Mars would never feel rain, never swim in an ocean, never experience weather beyond dust storms, never see the color green except in hydroponic gardens, never interact with the vast diversity of Earth's biosphere. Their entire existence would be confined to artificial habitats on a dead world, and if the life support systems fail, they die. That's not a childhood, it's a life sentence. Yet despite all these concerns, the one-way mission concept persists. Because the alternative, bringing people back from Mars, might be genuinely impossible with current or near-future technology. We've explored the technical challenges: fuel production, radiation exposure, physiological degradation. Each one is daunting. Together, they might be insurmountable. Which means if we're serious about putting humans on Mars within the next few decades, we might have to accept that it's a one-way trip. Not because we want it to be, but because we don't have another option. The technology for return simply doesn't exist yet, and might not exist for generations. This creates a strange paradox. The only way to establish a human presence on Mars might be to send people who can never leave. But is a human presence on Mars worth the cost of permanent exile for the people who go there? Is the scientific and exploratory value sufficient to justify asking people to die on another planet? Some argue yes, absolutely. Establishing humanity as a multi-planet species is worth almost any sacrifice. Others find the idea morally repugnant, viewing it as exploitation of people's dreams and ambitions for symbolic achievement with limited practical value. There's no clear answer, but what's becoming increasingly clear is that the romantic vision of Mars exploration brave astronauts planting flags and returning home as heroes might not be realistic. The actual future of Mars exploration might look more like permanent exile. Small groups of people committed to living and dying on an alien world, cut off from Earth in every meaningful way, struggling to survive in an environment that's actively hostile to human life. And here's what nobody wants to acknowledge. Even if we solve all the technical problems, even if we develop the technology to bring people back from Mars, we might choose not to use it. Because once you've invested the resources to establish a permanent settlement, bringing people back becomes a waste. You've built habitats, infrastructure, life support systems. You've created a functioning base. Why abandon it? The first Mars mission might be designed as a round trip, but the reality of settlement might transform it into a one-way journey, regardless of original intentions. This economic reality creates a trap that's almost philosophical in nature. The more resources you commit to making a Mars settlement viable, the less sense it makes to abandon it. You've spent billions establishing infrastructure. Why waste that investment by bringing everyone home? The settlement becomes its own justification for permanence. Not because permanence was the goal, but because permanence becomes economically rational once you've committed sufficient resources. It's a financial point of no return that has nothing to do with rocket fuel. Consider what this means for the first crew. They might launch believing they're coming back. The mission profile might include return vehicles, contingency plans, extraction protocols. But 2 years into their surface stay, mission control does the math. The cost of maintaining their return capability versus the value of an established base. The decision might be made for them, thousands of miles away, by people analyzing spreadsheets. You went to Mars as an explorer. You become a colonist, whether you agreed to it or not. This isn't speculation. It's already happening in the planning stages. Recent proposals from major space agencies include language about indefinite surface operations and multi-decade mission architectures. They're not calling it a one-way trip. They're just building missions where the return date keeps getting pushed further into the future until it effectively disappears. And here's the part that should concern everyone. The people most likely to volunteer for these missions are exactly the wrong personality type for permanent isolation. Astronauts are selected for their adaptability, their ability to handle stress, their performance under pressure. They're risk takers, adventurers, people who thrive on challenge and novelty. These are not qualities that translate well to spending 40 years in the same habitat, eating the same recycled food, and performing the same maintenance routines. The explorer mindset requires new frontiers. What happens when your frontier becomes your prison? When the adventure turns into monotonous survival? When you've seen everything there is to see within walking distance of your habitat and there's nowhere new to go? Psychological studies of Antarctic research stations, the closest Earth analogue we have to Mars isolation, show disturbing patterns. After 18 months, crew cohesion begins to break down. People develop intense irritations with minor habits of their colleagues. Conflicts escalate. Depression rates spike. And that's in an environment where you can leave if things get bad enough, where rescue is possible, where the mission has a defined end date. Now remove all those safety valves, make it permanent. Add the knowledge that any conflict could be fatal because you're completely dependent on each other for survival. The psychological pressure becomes almost unbearable. There's a reason Antarctic stations rotate crews regularly. It's not just logistical, it's psychological necessity. People need an endpoint. They need to know the isolation is temporary. Without that, the human mind starts to fracture in predictable ways. Mars colonists won't have rotation schedules. They'll have life sentences. And we have no idea how the human psyche responds to that level of permanent isolation, especially when combined with the knowledge that Earth exists, but is completely unreachable. You can see it from your window, this blue-green dot in the sky. Everyone you've ever known is there. Every place you've ever been. The entire human experience except for the few people trapped with you in this metal box. That's not just isolation, it's a special kind of torture. Some argue we'll adapt. Humans are resilient. We've survived in extreme environments throughout history, but we've never survived in an environment this hostile where return is impossible. Every extreme environment on Earth, from the Arctic to the deep ocean, people went knowing they could leave. That psychological safety net matters more than we acknowledge. The Mars colonist doesn't have that net. There is no leaving. There is no going home. There is only this: the same red rocks, the same dust storms, the same recycled air for the rest of your natural life. And that life might be significantly shorter than you planned. Because here's something else nobody wants to discuss: the medical impossibility of long-term Mars survival. We've talked about radiation exposure, the cancer risk, but that's just one aspect of a much broader health crisis that would face permanent Mars residents. The human body is exquisitely adapted to Earth-specific environment. 1 g of gravity, a 24-hour day, atmospheric pressure at sea level, a magnetic field that shields us from cosmic radiation, an oxygen-rich atmosphere. All of these factors shape our physiology in ways we're only beginning to understand. Change any one of them significantly and health problems emerge. Change all of them simultaneously, and you're conducting an experiment in human biology with completely unknown outcomes. The gravity issue alone is damning. We know astronauts lose bone density in microgravity, about 1% per month. Mars has gravity, but only 38% of Earth's. Will that slow the bone loss, stop it entirely, or just reduce it to a pace where your skeleton gradually dissolves over decades instead of months? Nobody knows. We have zero long-term data on partial gravity exposure. The only gravity environments we've studied are Earth's 1G and space's 0G. Mars sits in between, unexplored territory for human physiology. Early research suggests it's not enough. That partial gravity below 0.4 g won't maintain bone density or muscle mass long term. Mars is 0.38 g, right at the threshold where your body might slowly waste away despite every countermeasure we can devise. Imagine arriving on Mars at 35, healthy and strong. By 45, your bones are brittle. By 55, standing upright is difficult. By 60, you're effectively disabled. Your skeleton unable to support your own weight, even in Mars's reduced gravity. And there's no treatment because all our medical knowledge assumes Earth gravity. We don't know how to maintain bone health in 0.38 g because we've never tried. This isn't science fiction doomsaying. It's basic physiology. Your bones respond to mechanical stress. They rebuild based on the loads they experience. Reduce those loads by 62%, and they adapt by becoming weaker. That's not a bug. It's a feature. Your body is efficiently allocating resources based on perceived need. It perceives less need for strong bones in low gravity, so it stops maintaining them. The same applies to muscles. Your heart, Your cardiovascular system. Everything adapts to the lower gravity, and those adaptations make you less capable of surviving in Earth's environment. You become a Mars-adapted organism, unable to function in the environment where humans evolved, which means even if we solve the fuel problem, even if we develop the technology to bring people back, they might not survive the return journey. The acceleration of launch alone could break bones weakened by years in low gravity. The 6-month journey in 0G would accelerate the degradation, and arriving back at Earth's 1G, that might be immediately fatal. Your heart, weakened by years of pumping blood in low gravity, suddenly has to work 3 times harder. Your bones, already fragile, experience loads they haven't felt in years. Your muscles can't support your own weight. You'd need months of rehabilitation just to sit upright without passing out. And that's assuming your cardiovascular system doesn't simply fail under the strain. We've seen this with astronauts returning from the ISS after 6 months. They need assistance to walk. They experience orthostatic intolerance, where standing causes blood pressure to drop dangerously. Their exercise regimens in space, 2 hours daily of resistance training, barely mitigate these effects. And that's after 6 months in 0G with the knowledge they're coming home. Now extend that to years in partial gravity with no return date. The physiological damage might be irreversible. Your body might change so fundamentally that Earth becomes as alien to you as Mars was when you arrived. This creates a biological one-way trip to complement the technological one. Even if the rockets work, even if the fuel is waiting, even if every system functions perfectly, the colonists themselves might be the limiting factor. Their own bodies might make return impossible, and that's assuming they survive long enough to attempt return at all. Because Mars itself is actively trying to kill you through mechanisms we're still discovering. The radiation exposure we discussed earlier doesn't just increase cancer risk, it causes cognitive impairment. Studies on mice exposed to radiation, similar to cosmic rays, show permanent brain damage, memory problems, difficulty learning new tasks, anxiety and depression. These effects appear months after exposure and persist indefinitely. Now imagine an entire colony experiencing gradual cognitive decline. Not immediately, not dramatically. Just a slow erosion of mental function over years and decades. Decisions become harder. Problem-solving skills deteriorate. The very intellectual capacity you need to survive in such an unforgiving environment slowly degrades beneath the constant radiation bombardment. You can't shield against it completely, not with any technology we currently possess. The habitat walls provide some protection, but cosmic rays penetrate everything. Going outside for maintenance or exploration means direct exposure. And you'll need to go outside regularly because equipment fails, systems need repair, and the habitat requires constant upkeep. Every spacewalk is a gamble with your long-term cognitive function. Every hour spent on the surface is another dose of radiation your brain will never fully recover from. By the time you're 50, you might have the mental capacity of someone with early-stage dementia. By 60, you might not remember why you came to Mars in the first place. This is the reality nobody wants to acknowledge when they talk about Mars colonization. It's not a bold adventure into humanity's future. It's a slow death sentence, watching yourself and everyone around you gradually deteriorate physically and mentally while trapped in an environment that provides no reprieve, no escape, and no hope of return. The most honest assessment is this: the first Mars mission will be a one-way trip, not because we designed it that way, but because everything about Mars and everything about the journey makes return impossible. The fuel problem, the radiation exposure, the physiological degradation, the psychological isolation, the technological limitations, the economic realities. Each one alone would be surmountable, given enough resources and time. Together, they form an interlocking set of impossibilities that compound rather than cancel out. Solving one doesn't help if the others remain, and solving all of them simultaneously requires technology and resources we won't possess for generations, if ever. Which brings us back to the fundamental question: should we send people anyway? Knowing they can't return, knowing they'll suffer, knowing they'll die there. Is the goal of establishing a human presence on Mars worth that cost? Some argue the answer depends on what that presence accomplishes. If Mars colonists make discoveries that benefit humanity, advance our understanding of the universe, develop technologies that improve life on Earth, then perhaps their sacrifice has meaning. They become martyrs for human knowledge, pioneers who suffered so future generations could thrive. But what if they accomplish nothing? What if the colony struggles just to survive, consuming all its resources on basic life support, with nothing left for research or exploration? What if the psychological and physiological stress makes them less capable than robotic missions that don't need life support, don't experience radiation damage, and never complain about isolation? Then we've condemned people to death for symbolic value alone, to say we did it, to plant a flag, to satisfy our collective ego as a species. That's not noble. That's cruelty disguised as ambition. The ethical framework around Mars colonization tends to get wrapped in romantic language about human destiny and the pioneering spirit. We invoke the explorers who crossed oceans, the settlers who endured harsh frontiers, the astronauts who risked everything to reach the moon. Beautiful comparisons, completely misleading. Those explorers could turn back. Those settlers could return home if conditions proved unbearable. Those astronauts spent days or weeks in space, not years or decades. The comparison falls apart under scrutiny because none of those historical precedents involved permanent exile to an environment fundamentally hostile to human biology. Yet proposals for Mars missions continue treating this as a solved problem, or at minimum an acceptable risk. Organizations still recruit volunteers for one-way missions. Billionaires still promise cities on Mars within our lifetime. The public still believes we're maybe a decade away from regular flights to the Red Planet. We're not, and pretending otherwise does real harm. Consider what informed consent actually means in this context. You can't truly consent to something you don't fully understand, and nobody fully understands what decades on Mars will do to the human body and mind because we've never done it. The longest anyone has spent in space continuously is 437 days, and that was in low Earth orbit with regular resupply missions, constant communication with ground control, and the knowledge that emergency evacuation was theoretically possible. Mars adds entirely new variables: the partial gravity instead of microgravity, the isolation instead of proximity to Earth, the radiation environment instead of protection by Earth's magnetosphere, the complete self-sufficiency instead of regular resupply. We're extrapolating from incomplete data and calling it informed consent. How do you explain to a volunteer that they might develop dementia by age 50 from radiation exposure when we don't actually know if that will happen? How do you quantify the psychological impact of knowing you'll never breathe unfiltered air again, never swim in an ocean, never feel rain on your face? These aren't abstract philosophical concerns. They're daily realities that will wear down even the most mentally resilient individuals. The Mars One project demonstrated this problem perfectly. Over 200,000 people applied for a one-way mission to Mars. 200,000 individuals willing to leave Earth forever. On the surface, this seems like proof that people understand the stakes and accept them. Dig deeper and you find something more troubling. MIT researchers evaluated the Mars One plan and found critical flaws that would result in crew death within 68 days of landing. Not years, not decades, 2 months. The life support systems couldn't maintain proper atmospheric balance. Too much oxygen production led to fire risk. Reducing oxygen production meant nitrogen depletion, loss of pressure, asphyxiation. The Mars One organizers either didn't understand these problems or chose not to address them publicly. Meanwhile, 200,000 people signed up believing this was a viable mission. That's not informed consent. That's exploitation of public scientific illiteracy and the romance surrounding space exploration. Even well-intentioned proposals from legitimate space agencies face this consent problem. NASA's own assessments show current technology can't adequately protect astronauts from radiation during Mars missions. The dose limits they've established would be exceeded. They know this. They publish papers about it. Yet planning for Mars missions continues, as if this is a minor engineering challenge rather than a fundamental showstopper. You can design better shielding. You can select crew members less susceptible to radiation damage. You can plan shorter surface stays. None of it fully solves the problem because you can't escape cosmic radiation on Mars. There's no magnetosphere. The atmosphere is too thin. Going outside means exposure. Staying inside means slightly less exposure. Both options accumulate damage over time. The economic argument for one-way missions reveals even darker implications. Buzz Aldrin estimated one-way trips cost 3 to 4 times less than round-trip missions. Chris Kraft suggested 10 times less. The exact multiple doesn't matter. The principle is clear. We can afford to send people to Mars if we don't bring them back. This creates a perverse incentive structure where human lives become acceptable costs in a budget equation. Return capability is expensive, so we eliminate it and call the mission more feasible. We're not solving the technical challenges. We're just deciding some challenges aren't worth solving because dead astronauts are cheaper than living ones who come home. Corporate space ventures make this even worse. Private companies have different priorities than government agencies. Shareholders expect returns on investment. Timelines get compressed. Safety margins get reduced. The temptation to cut corners becomes overwhelming when you're burning through investor capital and need to show progress. SpaceX plans uncrewed Starship flights to Mars in 2026. Ambitious, probably necessary for testing systems, but the gap between successful uncrewed landings and safe human missions is enormous. We've landed robots on Mars multiple times. We've never brought a single sample of Martian soil back to Earth because the return journey is that difficult. Yet the same company talks about establishing a city on Mars, not a research outpost, a city. With civilians, families, children born on Mars, who will never experience Earth gravity, never develop the bone density and muscle strength required to survive here. Think about that carefully. We're discussing creating a population of humans who are permanently adapted to Mars, biologically incapable of returning to their species' homeworld. That's not colonization, that's speciation. We're talking about deliberately engineering a situation where humans evolve into something else because the environment demands it. Is that ethical? Is it even sane? The historical comparisons to colonization of the Americas or settlement of harsh frontiers break down here too. Those settlers faced difficult environments. They didn't face environments that fundamentally altered human biology across generations. A child born in Plymouth Colony could return to England. A child born on Mars could never come to Earth. We're not just sending adults who made informed decisions. We're creating a population with no choice in their circumstances, no possibility of leaving, no alternative to a life of constant medical intervention, just to survive baseline existence. Some argue this is the inevitable price of becoming a multi-planetary species. Extinction risk on Earth is real. Climate change, nuclear war, asteroid impacts, pandemics. Putting all humanity's eggs in one planetary basket seems foolish. Establishing a backup population on Mars provides insurance against Earth-based extinction events. Except Mars doesn't actually solve that problem. A Mars colony completely dependent on Earth for supplies, equipment, and genetic diversity isn't a backup. It's a remote outpost that dies the moment Earth stops supporting it. The colony would need to be entirely self-sufficient, not just for food and water, for manufacturing, medicine, education, genetic diversity, technological innovation, everything. We can barely maintain self-sufficient communities on Earth with full access to resources and favorable conditions. Antarctica research stations require constant resupply. Remote island populations struggle without outside contact. And these are places with breathable air and survivable temperatures. A truly self-sufficient Mars colony would need thousands of people minimum, probably tens of thousands. You need genetic diversity to avoid inbreeding. You need enough specialists to cover every critical skill. You need redundancy in case people die. You need a large enough population to maintain complex technology without outside help. Getting thousands of people to Mars with current technology would require hundreds of launches over decades. The cost would be astronomical, trillions of dollars, and every single person sent is gambling with their life on unproven systems in an environment that kills mistakes instantly. Who pays for this? Government space agencies have limited budgets. Private companies need profit. Even the wealthiest individuals can't fund a project this large alone. So we're back to the fundamental question: why are we doing this? If the answer is scientific research, robots are better. They don't need life support. They don't get radiation damage. They can operate in extreme conditions indefinitely. Every dollar spent keeping humans alive on Mars is a dollar not spent on actual research. If the answer is resource extraction, Mars has nothing we need. The cost of shipping anything back to Earth exceeds its value. There's no economic case for Mars mining. If the answer is human destiny or becoming a multi-planetary species, we're sacrificing real people now for an abstract concept that might never materialize. The first Mars colonists become martyrs for a dream that could turn into a nightmare. The psychological dimension of this makes it even worse. Astronauts selected for Mars missions will be the most mentally stable, resilient, adaptable individuals we can find. Extensive screening, years of training, psychological evaluation, the best of the best, that might get them through the journey. It might even get them through the first year on Mars. But 5 years, 10 years, 20 years of isolation, confinement, constant danger, no privacy, no escape, no relief. The human mind wasn't designed for that. Even the most stable people crack eventually. We've seen this in less extreme environments. Submarine crews on long deployments develop psychological issues despite extensive screening and training. Antarctic research teams experience depression and conflict during winter isolation. Prisoners in solitary confinement suffer permanent psychological damage. Mars is all of those combined and worse. You're in a submarine that can't surface. You're in Antarctica with no summer relief. You're in solitary confinement with a handful of other people you can't get away from. And one mistake, one moment of poor judgment, one equipment failure caused by psychological impairment kills everyone. The mission planners know this. Psychological support is part of every Mars mission proposal. Regular counseling, communication with Earth, carefully designed living spaces to minimize conflict. It's not enough. You can't therapy away the fundamental reality that you're trapped in hell and there's no way out. Some people might genuinely thrive in that environment. Rare individuals who find purpose in extreme challenge, who don't need the comforts and connections most humans require. Maybe 1 in a million. Those are your ideal Mars colonists, functional sociopaths who can endure decades of isolation without deteriorating. Is that who we want representing humanity on another planet? Because the selection criteria for surviving Mars long-term increasingly look like criteria for psychological abnormality by Earth standards. This creates a darker possibility nobody wants to discuss. What happens when the Mars colony develops its own culture, its own values, its own identity separate from Earth? Not over centuries, over decades, 1 generation. They'll resent Earth for sending them. They'll resent the comfortable lives people live here while they struggle to survive. They'll develop contempt for Earth's weakness, for our inability to handle the conditions they endure daily. The psychological distance will match the physical distance. Communication delays already create separation. 20-minute round-trip light delay means no real-time conversation. You send a message, you wait, you get a response, you wait. It's like the world's slowest text message thread. Relationships can't survive that. Friendships fade. Family connections dissolve. The Mars colony becomes isolated, not just physically but socially. Within a generation, they're not Earth humans living on Mars. They're Martians, with different priorities, different values, different goals. And unlike science fiction, they won't be superhuman. They'll be damaged, struggling, desperate people trying to survive in conditions that slowly kill them. That's the real future of Mars colonization if we pursue it with current technology and understanding. Not a bold adventure, not humanity's next chapter, a tragedy unfolding in slow motion, watched helplessly from Earth as people we sent there suffer and die for reasons that seemed important at the time, but ultimately weren't worth the cost. The ethical framework around Mars colonization tends to get wrapped in romantic language about human destiny and the pioneering spirit. We invoke the explorers who crossed oceans, the settlers who endured harsh frontiers, the astronauts who risked everything to reach the moon. Beautiful comparisons, completely misleading. Those explorers could turn back. Those settlers could return home if conditions proved unbearable. Those astronauts spent days or weeks in space, not years or decades. The comparison falls apart under scrutiny because none of those historical precedents involved permanent exile to an environment fundamentally hostile to human biology. Yet proposals for Mars missions continue treating this as a solved problem, or at minimum, an acceptable risk. Organizations still recruit volunteers for one-way missions. Billionaires still promise cities on Mars within our lifetime. The public still believes we're maybe a decade away from regular flights to the red planet. We're not, and pretending otherwise does real harm. Consider what informed consent actually means in this context. You can't truly consent to something you don't fully understand. And nobody fully understands what decades on Mars will do to the human body and mind because we've never done it. The longest anyone has spent in space continuously is 437 days, and that was in low Earth orbit, with regular resupply missions, constant communication with ground control, and the knowledge that emergency evacuation was theoretically possible. Mars adds entirely new variables: the partial gravity instead of microgravity, the isolation instead of proximity to Earth, the radiation environment instead of protection by Earth's magnetosphere, the complete self-sufficiency instead of regular resupply. We're extrapolating from incomplete data and calling it informed consent. How do you explain to a volunteer that they might develop dementia by age 50 from radiation exposure when we don't actually know if that will happen? How do you quantify the psychological impact of knowing you'll never breathe unfiltered air again, never swim in an ocean, never feel rain on your face? These aren't abstract philosophical concerns. They're daily realities that will wear down even the most mentally resilient individuals. The Mars One project demonstrated this problem perfectly. Over 200,000 people applied for a one-way mission to Mars. 200,000 individuals willing to leave Earth forever. On the surface, this seems like proof that people understand the stakes and accept them. Dig deeper and you find something more troubling. MIT researchers evaluated the Mars One plan and found critical flaws that would result in crew death within 68 days of landing. Not years, not decades, 2 months. The life support systems couldn't maintain proper atmospheric balance. Too much oxygen production led to fire risk. Reducing oxygen production meant nitrogen depletion, loss of pressure, asphyxiation. The Mars One organizers either didn't understand these problems or chose not to address them publicly. Meanwhile, 200,000 people signed up believing this was a viable mission. That's not informed consent. That's exploitation of public scientific illiteracy and the romance surrounding space exploration. The project collapsed in bankruptcy by 2019, having burned through tens of millions of dollars from investors who believed the dream. No habitat was built, no rocket was designed, no meaningful progress toward Mars colonization occurred. Just promotional videos and media appearances and a selection process that winnowed 200,000 applicants down to a final group who would never go anywhere because the entire enterprise was built on fantasy rather than engineering. Even well-intentioned proposals from legitimate space agencies face this consent problem. NASA's own assessments show current technology can't adequately protect astronauts from radiation during Mars missions. The dose limits they've established would be exceeded. They know this. They publish papers about it. Yet planning for Mars missions continues as if this is a minor engineering challenge rather than a fundamental showstopper. You can design better shielding. You can select crew members less susceptible to radiation damage. You can plan shorter surface stays. None of it fully solves the problem because you can't escape cosmic radiation on Mars. There's no magnetosphere. The atmosphere is too thin. Going outside means exposure. Staying inside means slightly less exposure. Both options accumulate damage over time. The economic argument for one-way missions reveals even darker implications. Buzz Aldrin estimated one-way trips cost 3 to 4 times less than round-trip missions. Chris Kraft suggested 10 times less. The exact multiple doesn't matter. The principle is clear. We can afford to send people to Mars if we don't bring them back. This creates a perverse incentive structure where human lives become acceptable costs in a budget equation. Return capability is expensive, so we eliminate it and call the mission more feasible. We're not solving the technical challenges. We're just deciding some challenges aren't worth solving because dead astronauts are cheaper than living ones who come home. Corporate space ventures make this even worse. Private companies have different priorities than government agencies. Shareholders expect returns on investment. Timelines get compressed. Safety margins get reduced. The temptation to cut corners becomes overwhelming when you're burning through investor capital and need to show progress. SpaceX plans uncrewed Starship flights to Mars in 2026. Ambitious, probably necessary for testing systems, but the gap between successful uncrewed landings and safe human missions is enormous. We've landed robots on Mars multiple times. We've never brought a single sample of Martian soil back to Earth because the return journey is that difficult. Yet the same company talks about establishing a city on Mars. Not a research outpost, a city with civilians, families, children born on Mars who will never experience Earth gravity, never develop the bone density and muscle strength required to survive here. Think about that carefully. We're discussing creating a population of humans who are permanently adapted to Mars, biologically incapable of returning to their species' homeworld. That's not colonization, that's speciation. We're talking about deliberately engineering a situation where humans evolve into something else because the environment demands it. Is that ethical? Is it even sane? The historical comparisons to colonization of the Americas or settlement of harsh frontiers break down here too. Those settlers faced difficult environments. They didn't face environments that fundamentally altered human biology across generations. A child born in Plymouth Colony could return to England. A child born on Mars could never come to Earth. We're not just sending adults who made informed decisions. We're creating a population with no choice in their circumstances, no possibility of leaving, no alternative to a life of constant medical intervention just to survive baseline existence. Some argue this is the inevitable price of becoming a multiplanetary species. Extinction risk on Earth is real. Climate change, nuclear war, asteroid impacts, pandemics. Putting all humanity's eggs in one planetary basket seems foolish. Establishing a backup population on Mars provides insurance against Earth-based extinction events. Except Mars doesn't actually solve that problem. A Mars colony completely dependent on Earth for supplies, equipment, and genetic diversity isn't a backup. It's a remote outpost that dies the moment Earth stops supporting it. The colony would need to be entirely self-sufficient, not just for food and water, for manufacturing, medicine, education, genetic diversity, technological innovation, everything. We can barely maintain self-sufficient communities on Earth with full access to resources and favorable conditions. Antarctica research stations require constant resupply. Remote island populations struggle without outside contact. And these are places with breathable air and survivable temperatures. A truly self-sufficient Mars colony would need thousands of people minimum, probably tens of thousands. You need genetic diversity to avoid inbreeding. You need enough specialists to cover every critical skill. You need redundancy in case people die. You need a large enough population to maintain complex technology without outside help. Getting thousands of people to Mars with current technology would require hundreds of launches over decades. The cost would be astronomical, trillions of dollars, and every single person sent is gambling with their life on unproven systems in an environment that kills mistakes instantly. Who pays for this? Government space agencies have limited budgets. Private companies need profit. Even the wealthiest individuals can't fund a project this large alone. So, we're back to the fundamental question: why are we doing this? If the answer is scientific research, robots are better. They don't need life support. They don't get radiation damage. They can operate in extreme conditions indefinitely. Every dollar spent keeping humans alive on Mars is a dollar not spent on actual research. If the answer is resource extraction, Mars has nothing we need. The cost of shipping anything back to Earth exceeds its value. There's no economic case for Mars mining. If the answer is human destiny or becoming a multiplanetary species, we're sacrificing real people now for an abstract concept that might never materialize. The first Mars colonists become martyrs for a dream that could turn into a nightmare. The psychological dimension of this makes it even worse. Astronauts selected for Mars missions will be the most mentally stable, resilient, adaptable individuals we can find. Extensive screening, years of training, psychological evaluation, the best of the best. That might get them through the journey. It might even get them through the first year on Mars. But 5 years, 10 years, 20 years of isolation, confinement, constant danger, no privacy, no escape, no relief. The human mind wasn't designed for that. Even the most stable people crack eventually. We've seen this in less extreme environments. Submarine crews on long deployments develop psychological issues despite extensive screening and training. Antarctic research teams experience depression and conflict during winter isolation. Prisoners in solitary confinement suffer permanent psychological damage. Mars is all of those combined and worse. You're in a submarine that can't surface. You're in Antarctica with no summer relief. You're in solitary confinement with a handful of other people you can't get away from. And one mistake, one moment of poor judgment, one equipment failure caused by psychological impairment kills everyone. The mission planners know this. Psychological support is part of every Mars mission proposal. Regular counseling, communication with Earth, carefully designed living spaces to minimize conflict. It's not enough. You can't therapy away the fundamental reality that you're trapped in hell and there's no way out. Some people might genuinely thrive in that environment. Rare individuals who find purpose in extreme challenge, who don't need the comforts and connections most humans require. Maybe 1 in a million. Those are your ideal Mars colonists. Functional sociopaths who can endure decades of isolation without deteriorating. Is that who we want representing humanity on another planet? Because the selection criteria for surviving Mars long-term increasingly look like criteria for psychological abnormality by Earth standards. This creates a darker possibility nobody wants to discuss. What happens when the Mars colony develops its own culture, its own values, its own identity separate from Earth? Not over centuries, over decades, one generation. They'll resent Earth for sending them. They'll resent the comfortable lives people live here while they struggle to survive. They'll develop contempt for Earth's weakness, for our inability to handle the conditions they endure daily. The psychological distance will match the physical distance. Communication delays already create separation. 20-minute round-trip light delay means no real-time conversation. You send a message. You wait. You get a response. You wait. It's like the world's slowest text message thread. Relationships can't survive that. Friendships fade. Family connections dissolve. The Mars colony becomes isolated not just physically, but socially. Within a generation, they're not Earth humans living on Mars. They're Martians, with different priorities, different values, different goals. And unlike science fiction, they won't be superhuman. They'll be damaged, struggling, desperate people trying to survive in conditions that slowly kill them. That's the real future of Mars colonization, if we pursue it with current technology and understanding. Not a bold adventure. Not humanity's next chapter. A tragedy unfolding in slow motion, watched helplessly from Earth as people we sent there suffer and die for reasons that seemed important at the time, but ultimately weren't worth the cost. The advocates for Mars missions will argue, I'm being too pessimistic, that human ingenuity will solve these problems, that we can't know what's possible until we try. That progress requires risk and sacrifice. Fair points. Historically accurate even. We've accomplished things that seemed impossible. We've solved problems that appeared insurmountable. Human capability for innovation shouldn't be underestimated. But there's a difference between difficult and impossible, between risky and suicidal, between pioneering and pointless sacrifice. We went to the moon knowing we could return. The mission was dangerous but achievable with existing technology. The risks were calculated and accepted by people who understood them. And we brought everyone home except the 3 who died in a ground test. Tragic, but not the inevitable result of environmental factors we couldn't control. Mars is fundamentally different. We're not talking about a few days in space. We're talking about years or decades in an environment that damages you constantly. And every proposal that claims to solve this either requires technology we don't have, or hand waves away problems that remain unsolved. The fuel production on Mars through in situ resource utilization sounds elegant until you examine the details. You need to find water ice, extract it, purify it, split it into hydrogen and oxygen. Combine the hydrogen with atmospheric carbon dioxide through the Sabatier reaction. Store the resulting methane and oxygen as cryogenic propellants. Keep them cold for potentially years without any boil-off. Each step has problems. Finding accessible water ice restricts where you can land. Extraction requires power. We haven't figured out how to generate reliably on Mars. The chemical processes need equipment that must work perfectly in Martian conditions for years. Cryogenic storage with zero leakage doesn't exist. We don't have valves that can maintain perfect seals indefinitely. And even if you solve all of that, you've only made enough fuel for one return vehicle. What if it fails? What if something breaks during the years it sits on Mars waiting? There's no backup, no second chance. The launch window back to Earth only opens every 26 months. Miss it, and you wait another 2 years, assuming you survive that long. The psychology of being trapped on Mars deserves more attention than it typically receives. You're not just dealing with physical survival challenges. You're dealing with the knowledge that every single day for the rest of your life, you'll wake up in the same hostile environment with no possibility of escape. Imagine that for a moment. Really imagine it. Every morning you open your eyes inside a cramped habitat module. The same walls you saw yesterday. The same recycled air. The same 3 to 5 people you've been living with for months or years. No fresh food, no weather, no seasons, no spontaneous trips anywhere, because stepping outside requires a spacesuit and careful planning. No privacy, because every square meter of habitable space is precious and shared. And this isn't temporary. This is forever. The psychological research on isolated, confined environments gives us some preview of what to expect. Antarctica stations, submarines, space stations. These provide data on how humans cope with isolation. The findings aren't encouraging for Mars colonization. Crew members on long-duration missions experience something called the third quarter phenomenon. About 3/4 of the way through a mission, morale plummets, productivity drops, conflicts increase, depression becomes common. This happens even when people know they're going home eventually. They can see the finish line. Mars colonists don't get a finish line. There's no date they're counting down to. No relief crew coming to rotate them out. The mission doesn't end. It just continues until they die. Research on Antarctic winter overcruise shows that even with modern communication technology, psychological problems are inevitable. Team cohesion deteriorates. Minor irritations become major conflicts. People develop cabin fever, depression, anxiety. Some experience psychological breakdowns requiring evacuation. Except on Mars, there's no evacuation option. The Mars One project, before its collapse, received over 200,000 applications from people claiming they wanted a one-way ticket to Mars. That number gets cited as evidence that humans are willing to make this sacrifice, proof that the psychological challenges can be overcome through proper selection. But those applications came from people sitting comfortably on Earth, romanticizing an adventure they couldn't truly comprehend. The reality of permanent Martian exile is something human psychology hasn't evolved to handle. We're social creatures. Our mental health depends on diverse social connections, new experiences, environmental variety. Mars colonies offer none of this. You get the same small group of people in the same enclosed spaces, doing the same survival tasks indefinitely. The communication delay with Earth compounds the isolation. Real-time conversation becomes impossible. Video calls happen with 6 to 40-minute delays, depending on planetary positions. You send a message. You wait. Eventually, a response arrives. By then, the conversation has moved on. Emotional support becomes difficult when comfort arrives 20 minutes after you needed it. Relationships with people on Earth will inevitably decay. Not because anyone wants them to, because the fundamental conditions for maintaining human connections don't exist. Your family and friends are living full lives on Earth, meeting new people, having experiences you can't share. Their world continues while yours remains frozen in the same Martian routine. Within a few years, you'll have more in common with your fellow colonists than with anyone on Earth. Their lives are still relatable. They understand the daily reality of Martian survival. Earth people are living in a world you can barely remember. Their problems seem trivial, Their excitement about things you used to care about feels alien. This psychological drift is inevitable, not a failure of character or commitment. It's the natural result of profound environmental separation. Consider the selection process for Mars colonists. What criteria would actually identify people capable of permanent exile? Traditional astronaut selection focuses on intelligence, technical skills, physical health, and psychological stability. These matter for short-duration missions. But permanent colonization requires something different. You need people who can maintain motivation and mental health while knowing they're trapped, who can form stable relationships with a tiny group while cut off from the broader human community, who can find meaning in repetitive survival tasks for decades. These might not be the same people who score well on traditional metrics. They might be people with personality traits we'd consider problematic on Earth. Extreme introversion, reduced need for social variety, comfort with routine bordering on obsessive. And even if you successfully identify such people, you're creating a colony of psychological outliers. The community dynamics won't resemble normal human societies. The culture that develops will be shaped by whatever personality characteristics allow people to tolerate permanent Martian confinement. That culture won't be a new branch of human civilization. It'll be a survivalist cult created by the extreme selection pressure of an environment that kills everyone who can't adapt to it psychologically. Then there's the question of purpose. What gives life meaning when you're trapped on Mars? The initial excitement of being part of history wears off. After the first year, you're not making history anymore. You're just trying to survive until tomorrow. Scientific research provides some purpose, but how much cutting-edge science can a small colony accomplish while dedicating most resources to basic survival? You're not running sophisticated experiments. You're growing food, recycling water, maintaining equipment, and sleeping. The grand vision of building a new civilization collapses when you're actually there. You're not building anything. You're maintaining minimal survival infrastructure while slowly dying from radiation exposure and bone density loss. Future supply missions might deliver new equipment, but they'll also deliver painful reminders of what you're missing. New colonists will arrive with stories of Earth, fresh accents, references to cultural events you weren't part of. They'll make you feel more isolated, not less. And those new arrivals will disrupt whatever fragile social equilibrium the existing colony has established. New personality conflicts, different ideas about priorities, competition for status in an environment where status distinctions are one of the few psychological rewards available. The Mars One project failed partly because MIT researchers identified a fatal flaw in the life support system. Following fire safety protocols would require oxygen levels that would deplete nitrogen supplies, causing loss of pressurization. The habitat would become uninhabitable within 68 days. But even if they'd solved that technical problem, the psychological architecture was doomed. Their plan involved sending new colonists every 2 years. Each batch would arrive to a deteriorating situation. Earlier colonists struggling with depression, health problems, and equipment failures. New arrivals would immediately regret their decision, but they'd be just as trapped as everyone who came before. This creates a nightmare scenario. People on Earth watching the colony decline. New volunteers still launching despite knowing what awaits them. Perhaps hoping things will improve. perhaps selected specifically because they lack the judgment to refuse. The colony becomes a dumping ground for people Earth is willing to sacrifice. Because make no mistake, that's what Mars colonization represents with current technology. Sacrifice. Not in the noble sense of giving something up for a greater good, in the wasteful sense of destroying human lives for no meaningful return. The advocates argue we need a backup for humanity, that Mars colonization ensures our species survives if Earth becomes uninhabitable. This argument falls apart under examination. Any catastrophe that makes Earth less habitable than Mars is difficult to imagine. Earth, after nuclear war, would still be more livable than Mars. Earth, during runaway climate change, would still have breathable air. Even Earth, struck by a large asteroid, would recover faster than Mars could be terraformed. Mars doesn't protect against existential risks. It creates new ones. Every resource devoted to Mars colonization is a resource not spent on preventing catastrophes on Earth or developing genuine solutions to existential threats. If we're concerned about species survival, we should focus on not destroying our one habitable planet, on solving problems here before they become unsolvable, on building sustainable systems on the world that already supports us. Mars colonization is a distraction, an expensive, deadly distraction that appeals to certain psychology because it feels like action, like humanity taking control of its destiny. In reality, it's running away from problems instead of solving them. The same resources required for a marginal Mars colony could revolutionize life on Earth. Advanced recycling systems, sustainable energy infrastructure, solutions to food and water scarcity. These technologies would benefit billions of people instead of condemning dozens to slow death on a hostile world. There's also something deeply troubling about the selection of who goes to Mars. It won't be random. It won't be fair. The first colonists will be chosen from a pool of applicants wealthy or connected enough to be considered. The narrative will frame them as brave pioneers, but the reality will be more complex. Some will be true believers who genuinely think they're advancing humanity. Others will be running from problems on Earth. Some will be seeking fame or legacy. A few might be escaping legal troubles or failed careers. The motivations won't be pure, and the selection criteria will favor people willing to accept permanent exile, which should itself be a warning sign. As the colony struggles, the pressure to send more people will intensify. Not because the colony is succeeding, but because it's failing. Each crisis will be framed as requiring more resources, more people, more support from Earth. The sunk cost fallacy will take over. We've invested too much to quit now. And every time someone dies on Mars, the reaction won't be to question the entire endeavor. It'll be to honor their sacrifice and send more people to replace them. The colony becomes a monument to stubborn refusal to admit failure. This isn't speculation. It's how human institutions respond to failed projects that carry emotional and political weight. We double down. We reframe failure as learning. We convince ourselves that the next attempt will be different. Meanwhile, actual human beings are suffering and dying on Mars, not for science, not for humanity's future, for ego, for political legacies, for the inability of mission planners to admit they sent people somewhere they can't survive. The ethical implications are staggering. We're talking about creating a situation where people are trapped in an environment that slowly kills them. where their suffering is broadcast back to Earth for entertainment value, where their deaths are inevitable but we send them anyway? At what point does Mars colonization become something worse than exploration? When does it cross the line into deliberate harm? These aren't hypothetical questions. They're practical considerations that need answers before we send anyone on a one-way trip. And the current proposals don't have those answers. They have optimistic assumptions and hand-waving about future technology solving current problems. Human missions to Mars with current technology means condemning people to death. Slowly, painfully, publicly. While Earth watches and pretends it's noble, the truth we need to confront is simpler than the technical challenges. We don't need Mars colonies. We need to fix Earth. Every argument for Mars colonization crumbles under scrutiny. The backup civilization concept assumes Mars offers protection from existential threats, but it doesn't. Any catastrophe that makes Earth uninhabitable would leave Mars still worse. Asteroid impact. Earth's damaged atmosphere beats Mars's non-existent one. Nuclear war. Radiation-soaked Earth remains more survivable than radiation-soaked Mars without a magnetosphere. Climate change. Even a runaway greenhouse effect on Earth leaves us with more atmospheric pressure and protection than Mars offers. The technological development argument is equally flawed. Yes, Apollo program spin-offs benefited society, but that's not an argument for Mars colonization. It's an argument for well-funded research programs. We could achieve the same technological advancement by directly investing in the problems we're trying to solve. Water purification, closed-loop life support, radiation shielding. These technologies don't require a Mars colony to justify their development. They're needed on Earth right now. Consider the resources required. SpaceX estimates roughly 60 heavy lift launches just to get propellant to Mars for a return mission. Each Falcon Heavy launch costs approximately $150 million. That's $9 billion just for fuel delivery, not including the spacecraft, life support systems, habitats, or the actual mission infrastructure. MIT's analysis of the failed Mars One project calculated $4.5 billion just for initial supply delivery. And that was for a permanent settlement without return capability. Now multiply those figures by what's actually needed for a viable colony, not 4 people in a habitat. A sustainable population requires genetic diversity, redundant systems, manufacturing capability, medical facilities, and enough people to maintain all of it. We're talking hundreds of billions of dollars minimum, probably trillions, when accounting for ongoing resupply missions until the colony achieves self-sufficiency, which might never happen. What could that money accomplish on Earth? The entire annual budget of NASA is around $25 billion. The money required for one Mars colony could fund NASA's entire operation for years. It could revolutionize renewable energy infrastructure. It could solve water scarcity in developing nations. It could fund medical research that saves millions of lives. But the economics aren't even the strongest argument against Mars colonization. The human cost is. Let's walk through what actually happens to the first colonists. They land on Mars after 6 months in space, already having received 60% of their lifetime radiation exposure during the journey. Their bone density has decreased by roughly 6%, their muscle mass has atrophied, and their cardiovascular system has begun adapting to microgravity in ways that make Mars's partial gravity insufficient to maintain health. They step out onto a world where the atmospheric pressure is 0.6% of Earth's, where temperatures regularly drop to -80 degrees Celsius, where the soil contains perchlorates toxic to human biology, where the radiation exposure continues 700 times higher than on Earth's surface, bombarding them with cosmic rays that damage DNA, increase cancer risk, and cause neurological degradation. Their habitat becomes their prison, not metaphorically, literally. Stepping outside requires a full spacesuit. A small tear means death in under 2 minutes as the low pressure causes fluids to vaporize. A solar storm could trap them inside for days while radiation levels spike to immediately lethal doses. Equipment failures aren't inconveniences, they're death sentences. The psychological impact compounds over time. You wake up every day knowing you're trapped, knowing that every system keeping you alive could fail, knowing that help is, at minimum, 2 years away and probably not coming at all. You watch Earth in the sky, a bright blue dot containing everyone you've ever known, everyone you'll never see again. The communication delay means conversations are impossible. You send a message and wait 20 minutes for a response. Relationships become asynchronous exchanges where context is lost and intimacy impossible. After a year, your bone density has decreased by 12%. The exercise protocols aren't working well enough. Your teeth are loosening. You're developing kidney stones from calcium leaving your bones. The radiation exposure has likely initiated several cancer processes in your body, though you won't know which ones for years. Your vision is degrading as cosmic rays damage your optic nerves. You're experiencing cognitive decline as your brain tissue accumulates radiation damage. The colony's life support system is struggling. The closed-loop recycling can't achieve perfect efficiency. You're slowly losing water, oxygen, nitrogen. Each resupply mission from Earth is delayed or scaled back due to budget concerns. The crops aren't yielding as expected. The hydroponics system keeps developing algae blooms that consume oxygen faster than plants can produce it. Someone gets sick, not space sick, actually sick. Appendicitis. On Earth, it's a routine surgery. On Mars, it's a crisis. Your colony has basic medical supplies, but no surgical capability. The infected appendix ruptures. Sepsis sets in. You watch your colleague die over 3 days because there's no way to treat them. There's no medevac option. No hospital to rush them to. They die, and you bury them in Martian soil, and everyone remaining knows they could be next. The psychological deterioration accelerates. 2 colonists develop severe depression. 1 becomes suicidal. Your mental health support consists of delayed video sessions with an Earth-based therapist who can't really understand what you're experiencing. Antidepressants help somewhat, but they're running low and the next resupply isn't for 8 months. Year 3, your body has adapted to Mars in ways that make Earth return impossible, even if a ship arrived tomorrow. Your bone density is down 30%. Your cardiovascular system can't handle even Mars's partial gravity well. The radiation damage is cumulative and irreversible. You've developed cataracts. Your immune system is compromised. You're aging at an accelerated rate, showing tissue damage equivalent to a decade of normal Earth aging. The colony's population is declining. 2 dead from medical emergencies. 1 from a habitat breach during a dust storm. 3 chose to end their lives rather than continue suffering. The remaining colonists are maintaining systems designed for twice their number. Everyone is overworked, sleep deprived, and slowly dying. This isn't speculation. This is what happens when you put humans in an environment they didn't evolve for, without the technology to adequately protect them, with no possibility of rescue or return. The Mars One project failed before sending anyone, but its failure illuminates the problem. MIT researchers calculated the environmental system would kill colonists within 68 days due to oxygen imbalance. The proposed solution required 15 Falcon Heavy launches instead of 6, tripling costs beyond available funding. And this was for a permanent settlement where return capability wasn't even attempted. They couldn't solve the basic life support challenge with unlimited time and no requirement to bring people home. Now consider that actual return missions are exponentially more complex. The Mars Ascent vehicle needs to manufacture its own propellant on Mars, squeezing it from the thin atmosphere using a Sabatier reaction. This requires keeping cryogenic propellants cold for up to 4 years without boiling off, despite the complete absence of valves with zero leakage. The vehicle sits on Mars for years, exposed to dust storms and temperature extremes, waiting to perform a launch that's never been tested in Martian conditions. The power requirements alone are staggering. Current proposals need a 100-fold increase in surface power systems beyond what NASA is developing. 1 megawatt capability requires 25 separate 40-kilowatt fission units. We're talking about establishing a nuclear power infrastructure on Mars before humans even arrive, maintaining it remotely for years, and trusting it to work perfectly when lives depend on it. Every step adds complexity. Every complexity adds failure points. Every failure point means dead colonists. And for what? What's the actual benefit that justifies this human cost? The answer keeps coming back to abstractions, inspiration, the frontier spirit, ensuring humanity's survival, pushing technological boundaries. These sound noble until you attach them to real people dying real deaths on a real planet that's trying to kill them. We're not talking about exploration. The Apollo astronauts explored the moon and came home. We're not talking about research. We can study Mars better with robots that don't need life support and can survive conditions that would kill humans instantly. We're talking about permanent exile to a hostile environment where survival is unlikely and quality of life is guaranteed to be miserable. The selection process for Mars colonists should disturb us. It's framed as choosing the best and brightest, but it's actually selecting for people willing to accept permanent exile and probable death. That's not a normal psychological profile. Well-adjusted people with strong Earth connections don't volunteer to never see their families again. The selection criteria inevitably favors those running from something or seeking something they can't find on Earth. This creates a colony populated by individuals with complex motivations and psychological profiles that might not be compatible with the extreme stress of Mars survival. You're not getting astronauts who train for a mission and come home. You're getting volunteers for permanent exile, which correlates with different psychological patterns entirely. The mythology around Mars colonization borrows heavily from historical exploration, but the comparison fails. The Pilgrims could breathe Plymouth's air. Lewis and Clark could drink from streams they discovered. Even Antarctic researchers can step outside without a spacesuit and won't die if their equipment fails. Mars is fundamentally different. It's not a harsh environment humans can adapt to. It's an environment that requires constant technological intervention to prevent immediate death. We keep circling back to the same point. Current technology cannot support human life on Mars in any sustainable way. The radiation alone makes long-term survival questionable. The bone density loss makes return impossible. The psychological stress is unprecedented. The life support challenges are unsolved. The fuel production for return vehicles is theoretical. The cost is astronomical. And every credible analysis reaches the same conclusion. We're not ready. We won't be ready for decades, maybe generations, maybe ever, because some of these challenges might not have solutions. You can't give Mars a magnetosphere. You can't substantially increase its gravity. You can't create a breathable atmosphere. The fundamental problems with Mars as a habitat are planetary-scale issues that no amount of technology can completely overcome. So why are we still talking about sending humans there? Because the idea is compelling. Because it sounds visionary. Because there's money and prestige in being part of humanity's next giant leap. Because admitting we can't do something feels like giving up. Because the people promoting Mars colonization have invested their careers and reputations in making it happen. None of these are good reasons to condemn people to death. The responsible approach is obvious. Continue robotic exploration. Develop the technologies we'd need for human missions. Test closed-loop life support on Earth and in orbit. Solve the radiation shielding problem. Create sustainable food production in controlled environments. Build the infrastructure that makes Mars missions survivable before sending anyone. If that takes 50 years, fine. If it takes a century, fine. If we discover it's fundamentally impossible with any technology we can conceive, that's fine too. Because the alternative is sending people to Mars with current technology and watching them suffer and die for no good reason. The first Mars colonists won't be heroes. They'll be victims of humanity's inability to admit we're not ready, victims of optimistic assumptions that ignore physical reality, victims of the sunk cost fallacy as missions continue despite mounting evidence they shouldn't. We owe it to them to be honest. Mars colonization with current technology means death. Slow, painful, public death while Earth watches and pretends it's noble. That's not exploration. That's not advancing humanity. That's sacrificing people for an idea that isn't ready for implementation. The universe isn't going anywhere. Mars will still be there when we've developed technology that makes colonization survivable rather than suicidal. Until then, we have a planet that already supports human life. A planet we're slowly destroying through the same short-term thinking that wants to establish Mars colonies before we're ready. Fix Earth first. Develop the technology properly. Then, maybe, we can talk about Mars. But not yet. Not with current technology. Not when it means condemning people to certain death. That's the truth nobody wants to say out loud. Mars colonization right now is a death sentence dressed up as destiny. The first humans to land on Mars will almost certainly never return to Earth. Not because of a catastrophic failure or tragic accident, but because return was never truly possible with the technology we're using to send them. This isn't pessimism, it's physics. It's biology. It's the accumulated weight of every challenge we've examined, each one solvable in isolation, but insurmountable when combined with all the others. The fuel that can't be reliably produced, the radiation that can't be adequately shielded, the bodies that adapt to Mars in ways that make Earth unsurvivable, the minds that break under isolation we've never tested, the economics that make one-way trips the only affordable option. We're standing at a crossroads where ambition meets reality, And reality is trying to tell us something we don't want to hear. Mars colonization with current technology isn't bold exploration. It's human sacrifice with better marketing. The people who go will be volunteers. They'll understand the risks, or think they do. They'll believe in the mission, in humanity's future among the stars, in being part of something larger than themselves. And they'll die on Mars, slowly, their bodies deteriorating, their minds fracturing, their suffering broadcast back to Earth as entertainment or inspiration or cautionary tale, depending on how the narrative gets framed. Earth doesn't need Mars colonies. It needs solutions to the problems we're running from: climate change, resource depletion, political instability. None of these get solved by abandoning the planet. They get solved by the same human ingenuity and resources we're planning to pour into making Mars marginally habitable for a handful of people who will suffer there. The money required for one Mars colony could transform life on Earth for billions. The technology we'd develop to survive on Mars would be more useful applied to surviving on the planet we're already destroying. The human cost of Mars colonization buys us nothing except the ability to say we did it, which won't matter much to the people dying in Martian habitats while Earth watches. This isn't an argument against space exploration. It's an argument for honest evaluation of what's actually possible versus what sounds inspiring in press conferences. Robots can explore Mars better than humans. We can study the planet, learn from it, prepare for eventual human presence when the technology actually exists to make that survivable. But that technology doesn't exist now. It won't exist in 2030 or 2035 or whenever the next optimistic timeline promises humans on Mars. It might not exist for generations. And pretending otherwise, sending people anyway, hoping technology will solve problems we haven't solved yet. That's not exploration. That's gambling with human lives where the house always wins. The first Mars mission will be one way, whether we admit it in the mission planning or discover it when return becomes impossible. The colonists will adapt to Mars in ways that prevent returning to Earth. Their bodies will change. Their minds will change. They'll become something other than Earth humans, not through planned evolution, but through survival adaptations to an environment that's killing them slowly. And we'll watch it happen. We'll see the delayed video feeds. We'll read the reports of equipment failures and medical emergencies and psychological crises. We'll witness the colony's population declining as people die from causes we predicted but couldn't prevent. And we'll send more people to replace them because admitting failure means acknowledging we condemned the first crew for nothing. That's the real future of Mars colonization if we pursue it now, before we're ready. Not a new chapter in human civilization, but a dark footnote about hubris overcoming reason, about choosing to do something because we could rather than because we should, about sacrificing real people for abstract concepts that sound profound until you attach them to actual human suffering. Mars will still be there in 50 years, in 100 years, in 1,000 years. The universe operates on timescales that make human impatience irrelevant. We have time to develop the technology properly, time to solve the problems that make Mars missions survivable rather than suicidal, time to be ready instead of rushing ahead because the idea of Mars colonies sounds inspiring. What we don't have is the right to send people to their deaths pretending we're advancing humanity. The first humans on Mars deserve better than being martyrs for a mission that wasn't ready. They deserve technology that actually works, life support that actually sustains, radiation protection that actually protects, return capability that actually exists. Until we can provide those things, Mars colonization remains what it's always been, an appealing idea that's not ready for implementation. And no amount of wanting it to be ready makes the physics cooperate, or the biology adapt, or the technology suddenly exist. The truth is uncomfortable but necessary. We're not ready for Mars. And the first people we send there will pay the price for our inability to admit it.